All right, everybody, welcome back. So today's lesson, as always, I'm most excited in these sessions to answer questions rather than to just kind of regurgitate the material that's already part of the lesson. Today's topic is a pretty important one, and it's not something, when we do something important in CS 125, we're not just going to kind of cover it and drop it. We're going to, keep coming back to it, right? So it's not like we expect you to understand inheritance, perfectly today. What we expect you to do is see some of the things for the first time, start to see some of the patterns and some of the syntax that, are involved with inheritance. And then this is something that we'll continue to look at. And so today's lesson introduces a way for us to establish relationships between our Java classes. And this is, one of these distinctive features of Java's object model. Now, one of the places where CS 125, I think, differs from, some other courses that cover Java is we don't place as much weight in inheritance as a design pattern. I am going to show it to you, and we'll talk about some places where it's appropriate. But in a couple of weeks, we're also going to talk about a different way of enabling a similar type of capability using a feature of Java called interfaces that I actually think is a lot more powerful and in many cases a lot more useful. But inheritance is a feature of Java, and there's places where it really makes sense, right? And over the next couple of days, we'll not only show you the syntax and talk about what this means, but we'll talk about some places, and we'll give you some homework problems to look at that are kind of good examples of places where you would want to use inheritance to enable certain patterns. Okay, so here's the new piece of syntax here. And again, one of the things we try to get you guys to do is take sort of an inductive approach to parsing code. And I think this is really useful because despite the fact that I will try to kind of show you as much of Java as I can in one semester, I'm never going to show you all of it. And we don't have time, and there's parts of it that you're still going to find later. There's parts of Java that I still am discovering, right? Because they just don't ever get used, right? You can write Java for 10 years and never come across like a finalizer, for example, which I didn't know about at all. And one of my course staff had to tell me about at some point because it became important for some code that we were writing, but I didn't even know that was a thing. So anyway, so with any programming language, there are the heavy hitters. There's the stuff that gets used a lot, and then there's a long tail of sort of like fairly arcane, strange features that aren't super common. And so we try to stick in the area where we're showing you stuff it's in common use. But when you go off and you're writing your own Java code and doing cool stuff with computer science and programming and building cool things and having fun and changing the world and enjoying your capability to create, things that people can use, you will come across parts of the Java programming language that you don't understand. And so when that happens, my encouragement is always to kind of look at it, try to identify the parts that you do know, filter those out from the parts that are unfamiliar, and use that as a way to kind of, and then kind of experiment, try to understand like, what is this thing for? What does it cause to happen? What parts of this do I not understand? So when we look at this snippet, I see two class definitions here. I see a pet group before, so we'll talk a little bit about what that does. But other than that, what I see up here in the pet class is I see a pet class that defines one field, a string named name. I have a constructor that allows me to set the name, and I have a getter. So this name is essentially a read-only field. It can only be set during construction when the object is being created. Okay, fine, right? Let's go down and look at dog. Now, here I'm starting to see some new stuff. So I haven't seen this before. This extends. Okay, so that, there's a little bit of, one piece where I might need to come back to, right? Inside the constructor, I see something interesting here. There's a couple of things to note. On some level, dog seems like another class that's defining one private field called breed and has the ability to set the breed when the dog is created, and then has a getter for the breed. So those parts I see. There's a few things that I find curious here. So the first thing is the dog constructor also takes a name parameter, which it's not using. instead it's passing, or I shouldn't say, there's no field on dog called name. So my set name parameter to the constructor is a little strange because I'm not using it the way I use it up here in the pet to just set a field. Instead, I'm passing it to something that looks like a method call to something called super, which I've never seen before. So that's, if I was noting things here, I would say, extends. That's one thing that I'm not sure about. Super. I might put a note here, what is happening to set name. These are my notes if I was new to this syntax and I was trying to understand this sort of inductively. You start by asking questions based on stuff that's not familiar to you. Protected, right? What is this? And in the future, obviously you can Google this stuff too, right? You can find lots of good answers. But it's good to kind of at least know what the questions are. Down here I see this, right? I have no idea what this is. I've never seen this syntax before, so I don't even, okay. Not sure what that is. And then, I see, so on some level, this looks like an instance method here that I've defined on the dog class, right? This is a method called toString. It returns a string, and I'm returning a string, which is great. I have some string concatenation going on with a literal. But here's the other thing that if I was reading this carefully, which we are, I would flag as a potential thing that is not clear to me, how am I accessing name, right? So name is not part of this class, right? It's not defined within the dog class. So I see, my declaration of dog. I have this extends bit here as part of the declaration. Then I'm a little bit curious about whether or not that's the source of some of this interesting stuff that's going on. But I don't see a private variable called name here. And it's not a parameter to the function called name. Breed, I understand what's going to happen here, right? Because breed is an instance variable as part of the dog class. And so when this string is evaluated and Java is trying to figure out what string to add here to include the breed, it's going to find this instance variable. There's no parameter called breed. And so it looks on the class description and says, well, every instance of a dog has a breed. I'll fill in the name of, I'll fill in the string that corresponds to that dog's breed. And so I know this, but this name thing is weird, right? Because again, I don't see name as a parameter to the toString function, and I don't see a private instance variable named name. And so, what's happening here, and what the lesson kind of continues on, is this is really all driven by this extends keyword. And extends allows me to create a relationship between classes. This relationship is one way. One of the other things I didn't mention that I'll include in tomorrow's lesson is that I can only extend one class. So when I create a class in Java, I have the option of extending another class. To do that, I add this to the class declaration. I say extends, that's a keyword in Java, that's why it's highlighted, and then the name of the class that I want to extend. What does this mean? So what it means is that dog inherits state and behavior from the pet class, whatever class it extends. So any public instance variables that are declared by pet, a dog will also have. Any public methods that are declared by pet, a dog will also have access to. I'll have access to on a dog instance, so I can call any of the methods defined in pet, as long as they're public. Or it turns out this new keyword protected. So when I extend another class, I gain access to all of its public or protected methods and variables, instance methods and instance variables. So you can almost think, and this is not, this might be like a semi-helpful model, right? You can almost think of this as if I had put this stuff, and I'm not going to indent this properly. It's almost, when I extend something, it's almost as if I've copied the constructor. Well, the constructor we'll talk about in a minute. But I've sort of copied the parts of the pet class that it's exposing as either public or protected into my class. And so this dog class now has a name field, which I'm using down here in the toString method. And that's because this is marked as protected. That's also be true if it was public. It's not true if it's private. We'll come back to that. I also have a getName method, and you can see this too. So I can print choo-choo, and then I can also print choo-choo.getName, and that's also going to work. The getName method is not defined on the dog class, but because dog extends pet, when you use dot notation to call the getName method on choo-choo, here's what Java does. Java says, okay, what's the type of choo-choo? Choo-choo's a dog. Okay, does the dog class define a method called getName that takes no parameters? No. Okay, but dog extends pet. Does the pet class provide a method named getName that's visible? Again, a visible method, public or protected in this case. In this case, it provides a public method called getName that takes no parameters. That's what gets called. And I could also, let's see, I can also probably get at the field here as well, because it's protected, and we'll talk a little bit about why this is, the lesson goes into a little bit about why this is later. So choo-choo also has this name field that, again, it inherits from pet. And we'll talk, like I said, we certainly can't introduce every aspect and use case of inheritance in one. We focused on the syntax today and understanding kind of the effect that the syntax has on our classes as they extend other classes. What we'll come back to when we talk more about design patterns that use inheritance is why, right? Why would I do this? Like, this seems strange. Or why not just put it all in one class, right? One thing that you might immediately be able to notice is that let's say I want to have multiple types of pet in my program. So I might want to have a dog as a pet, a lizard as a pet, a cat as a pet, different types of pets. By extending, so I could cut and paste the name field into all of those separate classes, but by extending pet, I don't have to do that. And so, and again, we'll talk more about kind of this design choice, right? When you have a group of objects that are related, if there's some feature that they all share in common, sometimes it's because they're all part of the same category. I would argue that a pet has a name. I think if you have a pet that doesn't have a name, it's not a pet, it's an animal. Right. Again, you could fight me about this, but let's not. So, every pet has a name. Now, there are different kind of pets. Lots of different kind of pets, right? Cats, dogs, turtles, lizards. I don't know why people keep some of those other things, but they do. Tigers, I don't know, weird stuff, pythons. People keep strange pets. So there's a lot of different types of pet. But if it's pet, it's got a name. And so all those different types of pets we might want to represent with different classes because they might have different features. Like, for example, if I have a python, it might be useful to know how long it is, right? Particularly if it gets out. Whereas a dog, I might care about the length of a dog, but I'm more likely interested in something like the dog's breed, right? Which I don't know if pythons have a breed or not, but I don't keep a python, obviously. So this is the idea behind classes, is this extension model, right? Is that I define, maybe one parent class pet, and I put all of the things that all pets have in common. Maybe pets also have an owner, so I could add an owner field to the pet class that would be the name of the pet's owner. Again, if it's a pet is really about a relationship an animal has with a human, and so it must be with somebody, right? The extension allows me to sort of more easily create a whole family of related objects or related classes, that share common features, right? So I pull all the common stuff into one class, like the pet class that describes everything that all pets have, and then I can subclass that pet class by extending it and add the features that individual kinds of pets might have that other pets don't, right? So this is the idea, but we'll come back more to sort of the design specification here in the next few lessons. All right, so that's it. One of the things that, one of the places where we let off here, and we'll come back to this, is with this, and I always like doing this, because I think, when you notice something about a programming language that you're using that doesn't make sense, and this happens to me still all the time, right? I'll be using a language and I feel like I know it pretty well because I've used it for a few years, and then I see some code written in it and it's surprising to me. There's something about it that doesn't make sense I've never seen before, or I can't understand why it's happening. And that's usually a good sign that you have more to learn, right? That there's something about the language that it's doing that's surprising. And so my example here points out that even if I create, so I've got this empty pet class here that defines no methods, no fields, nothing. It's just empty. It has a default constructor, and so I could create a new one. but it also seems to have this toString method that I can call. And we'll come back to that at the end of the lesson, but this sort of is one of the mysteries of Java's inheritance mechanism. Okay, so I already sort of went over a little bit about how extends works. With some of these examples, I apologize. I'm not going to use like full-on Java encapsulation with private fields and like setters and getters, because like the examples get really long, and so I just cheated and made the fields public. But for the sake of example, you can see what's happening, right? So by extending, and this is another case where a person is a more general category than a student. A student is a particular kind of person, or a person that's doing a particular kind of thing, right? If you were modeling, entities or people at a university, you might have a student class, a faculty class, a staff class, a graduate student class, I don't know, right? Different classes, but they're all people. And so you might have a class person that they inherit from that has attributes that are common to all the people then in the system, attributes that you care about. And then for individual entities within the system, if they're students or faculty, you might have a different number of things that type of class has that not every person has, right? Okay, so, and what you'll see here is that by extending the person class, U has a level, which is something that we added to the student class. That might be freshman, sophomore, junior, whatever. But it also has a name field. The name field is not defined as part of the student class. It's inherited from person. So one of the things to understand about extension, and I'll add a little bit more to these because I realized that I forgot to talk about multiple extension, but extension is one way, and it's with one other class. So you can extend one class, that's it. And you can't create circular extension relationships. So something like this doesn't make any sense, right? So if a class extends another class, at that point, that class can't turn around and extend some other class that would cause a cycle. The Java compiler will notice this and complain. We'll talk later in the semester about the data. So when you organize Java objects this way, it turns out that you form a data structure that we're actually going to come back and talk about in a lot more detail that's called a tree. So with the tree, every node has a single, you can think of objects or classes in Java's class hierarchy as nodes in a tree. Every node in the tree has a single parent. And it turns out that every Java class has at least, every Java class except one has a parent. Now you might wonder, well, I've been creating classes without extending anything. Yeah, but you were extending something. We'll talk about that in a few minutes. All right, so talk a little bit about how to use super. Super is the way of calling the constructor of your superclass. So if I look, we're sort of going through here, right? So we've talked about extends, and I understand what's happening here. That explains how I can access the name, although I'm not exactly sure about this protected thing yet, so I'll leave that here. Super. Super is the way of calling my parent's constructor. In this case, we've defined a constructor for pet, and it basically says that every pet has to have a name. When you create a pet, you've got to set the name. So when I create a dog, which is an instance of pet, a dog is also a pet. A dog is extended pet. And so in order to create a dog, I'm also creating a pet. And in order to do that, I need to make sure that I call the pet constructor. What this means, you'll notice, is that in order to create a dog, I have to provide all the information that I need to be a dog, which in this case is a breed, but then all the information I need to be a pet, which in this case is a name. So I have to pass all these fields to the dog constructor, which makes sense, right? Because again, a dog is also a pet. So every dog needs a name. The name is Choo Choo, and then a breed. What I'm doing with the name is I'm calling super, which calls my super class, or sometimes you'll see Java documentation tends to use the word super class. I like to use the word parent, but whatever. It calls my parent class or my super class. It calls this constructor to set the name. And when you extend another class, and when that class requires that you do some setup when you construct it, like in this case you pass a name, you have to do that first. That's the other thing that happens here. So if I try to run this, let's say I try to switch these two fields, you'll see that the Java compiler is going to flag this and say, when you need to call super, it has to be the first thing that you do in the child constructor. If my superclass or my parent does not have an empty constructor, a constructor that takes no arguments, I have to call super. And so if I remove this, you'll see that the Java compiler will also complain. And it's not completely, this is not the world's best error message, I would argue, but what it's telling you is that in order to create a pet, I need a name. You're a dog, but you're extending pet. So when I create a dog, I'm also creating a pet. You've got to provide a name. And the way you get around this is by using super. So this is the way to call your superclass constructor. When you don't extend another class, it turns out you do have a class, you still have a parent. We'll talk about who your parent is, but that parent does not have a constructor that takes a field, and so you don't need to call super. If your parent has a constructor that takes no arguments, you don't need to call super. Now we're getting a different error because of name. So let's look at this. So I can say public pet. Let's say I set name as my pet. This is silly. I wouldn't have this, but now, because I've created this empty constructor, you'll see that it says my dog, my pet is a mud. And that's because I didn't set the name on the pet. I just used this empty default constructor I created up here that takes no arguments that sets the name to a default value. In this case, I wouldn't have designed things this way because in order to be a pet, you got to have a name. All right, so super. There's a lot in this lesson, I know that. I apologize for it in the lesson itself. This is just kind of a big chunk of stuff. But don't worry, we're going to integrate over the next couple lessons, give you more practice with this stuff, and explain what's going on here more clearly and how you would use some of these features. So one important note is that by extending another class, we don't gain access to its private method. So if I mark this field up here as private, you'll see that now I can't access it in the child class. Now I have a public getter, and so I could do this, and that would work. Oh, I'm using it somewhere else. Oh, right here, yeah, let's get rid of this. So this would work fine, because the parent is providing now a public getter that I can still call. But if the field is private, I can't access it in the child. If the field is public, I can access it in the child. And if the field is what's called protected, this allows classes that extend the parent class to be able to directly access this field. So this is this protected modifier that we've been looking at. Now, there's a little bit more information in the lesson, which I'm going to gloss over because there's a lot to talk about protected and how it doesn't really work the way you would expect, particularly in our playground examples. But I'll let you go through that on your own. Okay. So now let's look at, now we're gonna do this, okay. Right, so now let's talk about kind of one of the fun pieces here, right, which is this, why does super need to be first? Good question. I don't know. I'll have to say, I mean, I think the idea is that you need to initialize the parent first. That's what Java is forcing you to do. Well, let's look it up. Why does super need to be first? I guess, I don't know. I don't know if I believe this. I mean, let's see. I'm not sure. I think that the answer is claiming that the superclass is, well, actually, let's check this out. So let's say that we set this to, well, actually, let's say it's protected, right? Now let's say that the, because if it's protected, notice that I can set the name directly in the constructor because I can access that field. So now let's do this, right? And now let's say name is equal to set name. Let's imagine that we could do something like this. So I think and that's not a terrible answer, right? I think the idea is that when you're writing a constructor, Java allows you to assume that nothing about the class has been set up yet, right? And so let's do this. So for example, I'll move this up here to make it a little bit more clear. So I've got this name field. What's the default value for a name field in Java? It's a string, and so the default uninitialized value would be null. And let's say that I do something in my constructor for the pet class that assumes that name is null. And this is something that I should be allowed to assume because I didn't initialize name here. Now, if I initialized it like to an empty string, then it's no longer null. But if I don't initialize it because it's an object in Java, the default uninitialized value for object instance variables is null. So I can assume that name is null when the pet constructor runs. Now, one of the other things that is, I think, really useful about that answer is that when you create a class in Java, your class shouldn't have to worry about children, right? This is a certain type of non-best for society sort of parent-child relationship here, right? Which is this idea that the pet class doesn't know anything about its children, and it shouldn't be required to know anything about its children. It should be able, the pet class needs to be able to work regardless of whether or not it has any subclasses. Put a different way, when you create a subclass, you shouldn't be able to break the superclass. So anything you do in your subclass should not be able to cause the superclass. Well, I shouldn't say that. Certain assumptions in the superclass need to still be true. And so the fact that the constructor, when I write a constructor, I'm allowed to assume that all of the state of the object is in this uninitialized state. If I ran the constructor last here, the subclass is now violating that assumption because it's changing name. Now, it's allowed to change name because I marked it as protected, but my constructor should still be able to assume that when it runs, nothing else has been set up. And so by putting super first, I ensure that the parent constructor gets to run before the child constructor does anything. And you'll notice that this works fine now because I can modify name in the constructor. I don't need to because parent is going to set up the name for me, but because the field is protected. Now, one thing is that if I mark this as private, right, now I would have to fix this and use the getter, but otherwise it would work fine. And so it's possible for my parent class to be fully encapsulated in the sense that all of its fields are private and it's providing getters and setters. And that's probably more common than the use of the protected keyword. It's more common to, in the parent class, still keep all of your instance variables or fields private and only provide access through getters and setters using the kind of pattern that we've already looked at. And so again, in this case, but in this case, I still want the constructor to be able to assume that it's the first thing that runs in the class. By making children call super first, that preserves that assumption. So I think that's a reasonable answer that we found through the magic of the internet. All right, so last thing we're going to talk about, and again, please go through the lesson because there's stuff in here that I haven't covered, is capital O object. And so, we go back to this puzzle that we started the lesson with of why can I call this toString method? And none of what we've talked about so far has really answered this question, right? Because it's like, okay, well, I can do this thing with inheritance, and okay, that's all nice and whatever, and I have to think a little bit differently about my classes now and stuff like that, fine. But my pet class in this example doesn't extend anything. So where is this toString method coming from? And so it turns out that lurking at the top of Java's class hierarchy. So, when I talk about top, what I'm talking about is a direction that you go in when you follow the extension. So if I take a class, I started a particular class. If it extends a class, I go to that class, I'm going one level up. And then if that class extends another class, I follow that, and then I follow that. At the very top of this, if I keep going and going and going, all roads lead to capital O object. So capital O object is the superclass of every class, a superclass of every class in Java. There's only one class in Java that does not have a parent, and that is object. The reason for this is that even if I don't explicitly extend something, what this is equivalent to is this. So when you don't use an extends as part of your class declaration, what you're doing here is you're still extending capital O object. Okay, well, now the idea is I know that every class has a relationship with capital O object. But how does this explain this toString thing? Well, let's see here. Object, that's not what I want. It's object Java 14. So let's look up, as we frequently do, the documentation for the object class. And what we're going to discover is that, as I've told you in different language, class object is the root of the class hierarchy. Every class has object as a superclass. So what that means is that all objects implement the methods of this class. Meaning that if capital O object provides a method, then every single class in Java has access to that method. So the methods that are provided by capital O object are available on any Java object. And one of those methods is this method called Tostring. And this is why I'm allowed to call this. Now, you'll see this, that it says the Tostring method for the class object returns a string consisting of the name of the class, the @, and the unsigned hexadecimal representation of the hash code of the object. And so when I run this, you'll see that I see pet, which is the name of the class, and then this hexadecimal. So hexadecimal is a numbering system that allows us to represent, normally with decimal we can represent 10 symbols. With hexadecimal we can represent 16 symbols. And the way we accomplish that is we go 0 through 9, that's 10 symbols. Then we add A, B, C, D, E, and F. So for 6 more symbols. So this is a hexadecimal string. And you see when we run this, every time that changes, but the name of the class stays the same. So by itself, this is going to make more sense tomorrow when we talk about polymorphism, but by itself, this object method is not particularly useful. However, there is a way to provide a more useful implementation of Tostring. And I'll show you how to do this. So Tostring, let's go look at the Tostring method. It says public string Tostring. So this method is public, it returns a string, and its name is Tostring. Let's see what happens if the pet class provides this method. Let's just see. So I need to return a string, and I'll say I'm a pet. Now, when I call choo-choo.toString, I see this I'm a pet printed, right? And so what happens, and again, we're going to continue to review this over the next couple lessons. So the question is, when Java starts executing this, how does it find the Tostring method to run? Because clearly there's multiple Tostring methods that are possible. If I remove this custom one, I get this other output that's created by the object class. If I add my custom one, I get the output that's returned by the custom Tostring method that I've added to the class. When Java tries to run a method using dot notation, it says, okay, what type of object is this? It's a pet. And it starts looking for a Tostring method in the pet class. If the pet class declares a Tostring method with the appropriate signature, which in this case is public string Tostring, then that's the method that gets run. If not, what happens is that it looks in pet's parent. Pet doesn't explicitly extend another class, so its parent is object. And so if I don't provide a Tostring method, then I get the one that's provided by object that produces the class name, @ and this hexadecimal string that's sort of meaningless. If I provide one, that's the one that gets used. If I don't provide one, I get this default one. So this is an example of what's called overriding. Even when my parent provides a method, I can override it in the class itself, and I can provide a different implementation of the same method. So let's go up here and look at this because we're kind of checking off the various bits here that we didn't understand, right? And I'll get rid of this. So now I got rid of the protected field anyway. I think that's totally fine because we'll just use the getter. But now let's say that so you'll see that my parent provides this getName method. I could also provide my own getName method, and I could say dogs got no names. It's kind of a silly name for a dog. I have to return it. Right, there we go, Geoff. And then what happens is that every dog now has the name dogs got no names, which is not a particularly good name for a dog. But you'll see when I call getName in the Tostring method, the first place it looks is on dog. If dog has a method called getName, that's the one that gets used. If it doesn't, then it goes into the pet class. If the pet class doesn't provide a method called getName, then it's going to look in object, and it's not going to find that method in object because we just looked through the object methods, and object doesn't provide a method called getName. There's really only 3 methods from object that we'll really cover in this class, and I talk about those in the lesson video. So that's why you get this error. I can't find this because it looked in pet, it looked in dog first, it looked in pet and couldn't find it. I put it back in pet and now everything works the way that I expect. Last piece of the puzzle before I kind of wind down and see if I can address any lingering question is this, what is this thing? So this is not something that we're going to delve into deeply in this class, and not something you'll ever be tested on. To be honest, not something you have to use. What this is, though, is a feature of Java called annotations. Annotations you can think of as almost like Post-it notes or sticky notes or labels or something. And you can attach them to methods, you can attach them to fields, you can attach them to classes. There's a bunch of places in Java where you can use an annotation. This annotation is attached to this method. And what the annotation does is it tells Java that this method should override something from one of my superclasses, okay? And so now let's look at what happens if I misspell the name of this method. So I'm trying to override this toString method because I want my dog to be able to, well, now I know how I'm accessing name, I want my dog to be able to print this nice string representation of itself, right? Now, if I misspell this, so let's see if I take off the override annotation. Now what happens is Java looks for a method called toString. It doesn't find one in dog. It doesn't find one in pet. It goes all the way up to object, finds the default one, and uses that. But I don't get this nice string that I'm trying to set up. When I use override, what it does is it tells the Java compiler this method should override a method in one of my superclasses. If it doesn't, I get an error, right? And so what you'll see is that the compiler is now warning me. It says, wait, you told me that this method was supposed to override something, but it doesn't. Your parent doesn't provide a method called toLowerCaseString. An object doesn't provide a method called toUpperCaseString, toUnderCaseString. And so you're not overriding anything here. And this is a good way to check whenever I override something to make sure that it's actually correct. And so this is what this is for. And again, this is one of these things that, is a feature of the Java programming language. You will see this in use in the wild. Annotations, you can create your own annotations. There's a whole another sort of style of programming in Java that this opens up, but not something that we use often in this class. But this is one place, this is a very, very common Java annotation. And it's one, it's just a way to make your programming a little bit more defensive, right? And it stops you from kind of silly errors. So the other thing you could do is, maybe your override method returns the wrong type, and now I get a similar error, right, about this method. So, all right, a lot of stuff to cover today. Hopefully, again, this is a big chunk of content. I get that. The homework problem's fairly straightforward, hopefully. So, but we'll get more practice with this over the coming days. So there's a question about, an example of, real world example using getters and setters. Every Java class in the real world uses this pattern. Having an instance variable be public is at this point, something they refer to in Java as an anti-pattern. It's just nobody ever does it. Maybe there's cases where it would be okay, but people just don't design classes that way. You pretty much, again, the default check style rules don't allow you to do that, right? If you try to create a public field, check style will complain and say, the field should be private and you should create a setter and a getter, basically. This is also super easy to do with today's IDEs because, they'll have here I can show you just quickly. Let's see. I wonder if I still have that little mini project that we created last time. Is there any code left in here? Yeah, okay. So last time, and I'll change my viewer here to show you this. Need to fix this to show. There it is. Okay. So I don't know. Some of you that watched one of the lessons recently asked about, can we create a class using an IDE just to see how that works? And we created this tic-tac-toe class, right? And so, one thing I'll do here is I'll say private. So we had this last player, right? That stored the last player that moved, and this was a completely private variable because we didn't need anyone to have access to it. But let's say that we want to enable access to it. So in IntelliJ, what I can do is I can actually say, let's see here, it's called generate, and basically it allows me to generate a getter and setter. I say which variable I want to use, I hit OK, and I'm done, right? It uses this syntax. I don't like that. You could fix this, but it's really that simple. So this pattern has become so ingrained in all the tooling and the design of Java that nobody really creates public fields anymore. It's just not done. The reasons for this are really the ones that we described, right? In the sense that I don't want to get rid of my actual variable, just the getters and setters, right? The reasons for this are the ones that we've covered in the past, where it's it just gives you a lot more flexibility. You can add code to the getter or the setter if you want to check the variables values as they're being set. A lot of times, I think that's probably one of the most common reasons, is that a lot of times a particular value has, like, the board, right? So we didn't make the board public and let people put pieces wherever they wanted. That would make it really difficult to implement the game logic, because we need to be able to assume that when people put a player on the board, they're following the rules of the game in terms of which player plays next, and that they're also playing a valid piece, either an X or an O. And so typically, probably the best answer to this question is that typically any instance variable in Java has semantics associated with it that are narrower than what the type allows. So let's see here. Let me go back to our example, right? So for example, the name of a pet. Null's not a very good name for a pet, right? Maybe the next, maybe the next dog get good, I'll name it Null. That would be kind of an inside computer science joke, right? But Null's not really a great pet name. And if you wanted to call it Null, you would probably call it string null, right? Not the null value. There are other, I might have rules about how long the name is. I might not allow you to name a pet an empty string, right? If I make the variable public, then I don't have any control over what you do. If I make it private and make you use either set it in the constructor or use a setter, now I have full control over things, and I can do things like, assert set name is not equal to null. I can assert set name I can assert set name dot equals, and then let's see, I'll say not, right? So I can make sure it's not the empty string. Maybe I have rules about how long your pet name could be, so I could say assert set name dot length is less than 32 characters. That seems reasonable for a pet name. And so I can layer, because I'm running code as part of setting the variable rather than just allowing you to set it directly, I have a lot more control over the semantics of the data. And I think that's probably the most compelling reason for setters and getters. But yeah, I don't, it's one of those things that's sort of interesting evolution of the language, right? When Java was released, they allowed this, right? They allowed you to mark fields as public, and I guess somebody thought it was a good idea. Over the years that people have been using Java, nobody does this, right? So now again, if you're doing this in industry, everybody's going to do it the same way. Create a private variable, create a setter and a getter. You can do this in IntelliJ very easily. And other Java IDEs. Newer, languages that interoperate with Java don't even give you a choice. They just, when you set up a class, basically what you get is a getter and setter, and you can customize those getters and setters, but and things that look like, so if you set a field directly, for example in Kotlin, if you set a field directly, what's actually happening is that there's a setter that's running, right? If you don't provide one, it uses a default setter that just does what you expect, but there's really no such thing as a public variable. So it's a good question. It's just interesting how sometimes you design features into languages and then the use of the language leads you in different directions about stuff. So I don't think Java will ever be able to make this change, right? But you could imagine if you didn't have to support old code that probably does use this, you could imagine if Java was able to start over, like wave a magic wand and kind of white blank sheet, design, they might not have public instance variables at all. They just might all be private by default. And I think in many ways that's better. So, fair question. All right, I will stick around in case there's just, any other questions come through. Otherwise, I will log out and let people get on with their day. It looks like it's a beautiful day outside, at least here in Champaign. I hope you guys are well, and I'll be back at the same place tomorrow.